Welcome. Today let's try to solve Leetcode problem 456, 132 pattern. Let me first explain the problem. So we have a nums array. So inside the nums array, it will be just numbers, and this number gonna be from minus 10 to the power of 9 to 10 to the power of 9. It will be very big numbers, and the length of the array is maximum 2 times 10 to the power of 5. And if we have array like this, let's check the second example, 3, 1, 4, 2, and we're gonna check the index as the sequence. So for example, if we choose 1, 4, and 2, we can choose a sequence of 1, 4, and 2. If the last number is in between the first and the second number, so we're gonna return a true. If we cannot find such a sequence, we're gonna return a false. Let me first explain my solution from the whiteboard and then go to the code editor to finish the coding. Now let's analyze this example. So we have numbers of 3, 1, 4, 2. Let's try to use this number. I don't know why we can. Let me just prepare 3 numbers like 3, 1, 4, 2. And for this problem, I'm going to solve it by the sorted list. So it is from the sorted container, in the Python library. So I'm gonna from sorted containers import the sorted list. So in the sorted list, if we are giving an array, it is in increasing order. For example, 1, 2, 3, and 4. So we can use So inside the numbers in the sorted list, it will be ordered in increasing order. And I can use a binary search to search the numbers. So for example, I can use a binary left or bisect. I can use a bisect left or bisect right. So for example, if I want to search the number 2, if I use a bisect left, it is at index 1. If I use a bisect right, so it is at index 2. So this is the difference between bisect left and right. So I'm gonna use this kind of library to solve the problem. Now let's analyze the problem. So for this problem, I'm gonna use enumeration to solve it. So I'm gonna check one by one. So first of all, I want to find the minimum numbers from the left to right. So for the first number, the minimum is 3. Now I want to check the next number if it is bigger than the minimum. So for this one, it is not bigger than 3. So I will not do anything. I will check the next number and I will set 1 as my minimum. So currently, 1 is my minimum number. So I'm going to check the next number if it is bigger than 1. So 4 is bigger than 1. So I'm sure 4 will be my next number. And then I want to find some other numbers in between 1 and 4. If there is a 2 in between 1 and 4, yes, there is. So I'm going to return true. But how can I find all those numbers in between 1 and 4? So I can use a binary search. So this is from the sorted list. I can use a bisect right to find this number 2. So for example, inside these containers, they are sorted and they are sorted list. Currently, there's only one number 2. So I want to find a number which is in between. How can I find one number in between? I have to use a bisect right. I cannot use a bisect left because bisect right means if I find a number, this number will always be bigger than 1 because I will choose 1. Because I want to use a bisect for the minimum number. I cannot use it for the maximum number 4 because I cannot use a bisect left or right to find a number more than this 4. I have to choose the smallest number, this 1, and then inside the container, I'm gonna find a number, for example 2, which is strictly bigger than 1. How can I find it? I can use a bisect left. I can use a bisect right. So if I use a bisect right, I'm gonna find an index, for example, currently it is 0. Yeah, it means it must have an index 0. So this 2, if I can find an index, so it means I must already find a number. It is more than 1. And then I'm going to check this number 2. If it is smaller than 4, I can return my result. So for this example, my index is 0, so it means I find a number. So for example, if inside there's no such numbers, for example, inside it is just 1, 1, 1. Yeah, but I want to use a bisect right to find a number more than 1. So the index will become 0, 1, 2, and 3. So it means it is out of the boundary. I cannot find that. So it means for my index, I have to check it must be less than my sorted list. Yeah, so I'm gonna use SL as my sorted list. So this container is a sorted list. If it is less than, and also this number 2, for example, must be smaller than this number 4, than my current number. So I'm gonna return true. If I cannot find such cases, I'm gonna return a false. I hope you understand, yeah, why I'm gonna use a sorted list to solve the problem. Basically, we're gonna find the minimum number first, and then try to find the next number, enumerate the next number. If it is bigger than the minimum number, so after that, it will be inside the sorted list. So inside the sorted containers, inside the sorted list, we're gonna find the number 2, which is in between 1 and 4. If I can find such cases, I'm gonna return true. Yeah, if after enumeration of all numbers I didn't find such cases, I'm gonna return a false. Now let's just go back to the code editor to finish the coding. As I explained, this library we have to import. Yeah, so for other libraries maybe we don't need, but for this sorted containers, sorted list, we have to import. Yeah, so so we can use from sorted containers import a sorted list. Yeah, this is sorted list. It means inside the numbers it will be in order, and while we add or remove a number, it is just log n time complexity. Yeah, and if we search a number, it is also log n time complexity. Now let me prepare a sorted list. So the SL means a sorted list. So inside the sorted list, it would be the numbers left behind. Yeah, if I choose two numbers, the first number and the second number, so what left behind is my sorted containers. So this is my sorted list. So from the third number, and after that, it will be, yeah, because I'm going to use the binary search to search the numbers in between my first and second number. Now, let me prepare the first number. So I'm going to define a min num as my first number. It's going to be nums0. Now I can use a for loop. So for I, so here I'm gonna use z because this is the index z in between I and k. So I'm gonna use the index exactly like that. So for z in range, because the first number is my minimum number, so I'm gonna start from index 1 and length of nums minus 1. Why? Because I need to at least have one number from my sorted list. Yeah, if I use len minus 1, it means this is my second number, and I still have a number which is inside the sorted list. Yeah. Now, I'm gonna check this number. Yeah, so if nums z is bigger than the minimum number, what I'm gonna do, yeah, I just use the bisect left to find the index. Yeah, I just needed to use the bisect right to find the right index. So I'm gonna use a k because here is a k. Yeah, I just needed to find the next one. K should be bigger than z. Yeah, so k should equal to sl dot bisect right, and inside it's gonna be the minimum number. Yeah, because we want to find a number which is bigger than the minimum number, the index which is k. So we have to check the k if it is inside the boundary, inside the sorted list. And also, I need to check the values of this index k, so the SLK should be less than, so this SLK should also be less than the nums j, because nums j is here, current number. So currently the conditions is this SLK, this number is less than my nums j, and my nums j is bigger than the minimum number. And also, while I use this k, this index, it means I already find a number which is this SLK. It must be bigger than the minimum. So this means my SLK is in between the minimum number and the maximum number. So for example, 1 and 4, I find a 2, which is in between. Because this SLK, if it is less than the length of sorted list, so this means the SLK must be bigger than the minimum number and smaller than the maximum number. This means we're gonna find one solution. We just need to return true. Otherwise, we need to prepare the minimum number should be updated to the minimum number with the current number, which is nums j. And the last operation, I need to so for the next loop, so here for the current loop it is nums j. For the next loop, I have to remove one value from the sorted list, and that value is just after this index j. So from the sorted list, I need to remove this j plus 1. This, let me explain it from here. So for example, if we have currently, for example, inside our sorted list, it is 4 and 2. But for the next loop, my index j will go to this 4. So this means my sorted container, I need to remove this 4. And this 4 is j plus 1. Currently it is j. And for the next loop, I need to remove it. So it is j plus 1 for the next one. And also, here I prepared a length of nums minus 1. This means it will always be inside the boundary. So actually this is the entire code. If we didn't find a true, we just needed to return a false. Now let me just run it to check if it works. Because inside we should to remove nums j plus 1. Now let me run it to check. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases, and it is not so fast because the time complexity is n log n. This is a one for loop, and inside for loop we use bisect right, and this is log n. So this is why it is not so fast. Actually, there's a ON algorithm. It should be used monotonic stack, but that will be harder to think. So for this video, I just prepared a sorted list. Thank you for watching.